My name is Richard Rahn. I'm a principal with a company called Leonardo Group Americas, and mixed model manufacturing, or maybe you could even call it high mix, low volume, is kind of what we do. So what I'm going to do in this webinar is share with you various approaches to material delivery that we've implemented or that we've seen, over the years. And the one that you choose will be, the one appropriate for your environment. So at the end of this webinar, I'm going to share with you an Excel-based decision matrix tool that you can use to kind of, and it's not super complicated, but you can analyze your own environment and do some brainstorming in terms of, what of the methods I'll be sharing with you would be best for you. Okay, so with that, let's get going. So the agenda for this webinar, I'm going to be talking about first of all, some definitions. So what do we mean by high mix, low volume? What do we mean by material flow? And then we'll jump right into the strategies and have 5 main ways of doing this that we'll analyze. And I think for every one of the methods or strategies, I actually have some examples or case histories of how this was done, with actual real companies. And then we'll get into the decision-making process, and I have a couple things that will help you. So we'll talk about the main parameters or the factors, the inputs you would need to kind of assess your own environment. And then you'll be able to download an Excel file during the webinar to, again, help you make that determination if that's something you're interested in. And then the final thing, which is fast, is, where do we go from here? There's some educational opportunities that are available for you in this arena of mixed model material flow or high mix, low volume. Okay, so let's get right into definition. It's not too complicated. What we're talking about here is in a manufacturing environment, an environment where you have a lot of different models or products within the same family. So that's an important thing to understand. We're not talking about mixing entirely different products. That might be a challenge. Like motorcycles and air conditioners on the same production line, that might be a bit of a stretch. But normally we're talking about a family of products that have characteristics in common and processes in common, but they're different. It could be, let's say I mentioned air conditioners, it could be different capacities, right? Different sizes. And they all have basically the same components, but some are bigger and some are smaller. Or you can have an environment where maybe the products are not that different, but you have configuration options that you can offer the clients. So configured products. So every one coming down the assembly line could be different in some way or another. Or you could have both. You could have a lot of different base models and options on top of that, if you're lucky enough to have that situation. But the point when it comes to material flow is, the main point is that you have a lot of different materials that you have to manage. And so what we're going to be talking about in this webinar is some strategies for handling that. How do you manage that effectively so you don't stop the line because you run out and you don't overburden the line with too much material. So that's the main issue, right? Lots of parts that we have to figure out how to manage. Now, your order quantity in a high mix, low volume, when we say low volume, how low is low? Well, it could be as low as 1, 1 unit, and then a different one comes. Or it could be small quantities of different products that you're running on the same line. And it could be on the same line, or it could be an assembly cell. So we've seen environments where you're not trying to mix everything on the assembly line. You're being more refined in terms of how you're defining your product groupings and doing the work in smaller assembly cells, let's say. But the issue of having to deliver those materials is still the same, right? Still, you have a lot of parts to manage. Now, specific examples, and there are lots. In fact, I would venture to say that most companies these days are mixed model manufacturers in one way or another, to greater or lesser degree. So this is not something rare, right? Most of us are dealing with this at some level. But here's some examples that come to mind. Building controls. So we're talking here, this is a specific company I'm thinking of, where they're building thermostats, sprinkler system controls, various air conditioning, HVAC controls for, in this case, for office buildings or larger buildings. And they had a policy of supporting their old products. So they're continually adding new products, but the old ones don't go away. So they ended up with a big challenge in terms of the complexity of the number of items that they had to support. And so that was a real issue. Literally thousands of different products that they built as long as 50 or more years ago, in some cases. Next example, this was a company in California we worked with. They were making insulation covers. If you have a jet engine, parts get hot. And so there are parts of the engine that you don't want to expose to direct heat. And so these engines, and in fact, the aircraft in general, has a lot of insulation blankets or insulation products. Now, the products themselves were very similar in terms of the materials that were used to make them, but lots of different options, thousands in this case. And so they had quite a challenge to deal with in terms of delivering what they needed to the assembly lines when every order could be different. And the final one is fork trucks. We've spent quite a bit of time, and we have a very strong relationship with Toyota Material Handling, the Toyota fork truck plant in Columbus. And they are a classical mixed model or high mix, low volume environment in the sense that almost every fork truck could contain some customer specified option, some unique thing. So, and they mix, right? So they very rarely will build the same model, the same base model, one after another. So it's a pure mix environment with options laid on top of it. And so we'll be talking in more detail about all of these examples as we go forward. Okay, and industries, just shifting the focus to what kinds of industries are high mix, low volume. Well, aerospace is one. It's clearly low volume. I mean, how many airplanes are built every year? Not that many compared to cars or a lot of other products, right? So this is kind of inherently low volume, but they have a lot of complexity. So aerospace would be an example. Electronics and computers, where there are a lot of different models typically available. And you'll know this if you've tried to order parts for a computer and try to find your model, and a list will come up of hundreds and hundreds or maybe thousands of different models. So we have complexity in that level. Industrial products tend to be high mix, low volume. They're kind of generally on the lower volume side, but these companies tend to offer a lot of different options, like electric motors, for example, or pumps, where you'll have lots of different capacities, sizes, a lot of options that they have to deal with. And in general, if you're a mixed model manufacturer, this is the environment in which you live, where you design a mixed model line for different models going down the same line that share a lot of same characteristics, but differences as well, especially when it comes to the parts. Now, what we're not talking about here are job shop environments. So in a flow manufacturing or mixed model environment, you have different models, but you basically have the same flow, right? The same assembly line or the same process flow. Whereas in a job shop, you have a lot of different models and you do not have a common flow. You have a lot of shared equipment and a lot of variety in terms of the product flow. So what we're addressing in this webinar is really the flow manufacturing or the mixed model environment and not so much a job shop environment. Okay, so we're almost ready to get into the different strategies, but here's our basic philosophy. Again, this is not rocket science. So if we have a good material delivery system, what we're wanting to achieve is pretty straightforward. We don't want to run out of parts. If you run out, then you can't support your customers, and you could be stopping the line as well with all the problems that entails. So we don't want to run out. But on the other hand, we don't want to address the not running out issue by having too much material, thinking that having too much or having a lot is going to address the not running out problem. That's not necessarily the case, right? You might have too much material and run out because you don't have the right stuff. So we want to achieve both of those things. And in achieving those things, we don't want to waste money. In other words, we want to do things efficiently. We don't want to have an army of people delivering parts one by one to the line and achieving very low inventory, but having a huge support staff to do that necessarily. And when we talk about doing things right, we have the seven rights of material flow that I'll just mention in passing. So put the word right in front of every one of these words. So we have the right part, the right quantity, the right location, the right container, the right sequence, the right time, and the right total cost. And the tool we use to really assess this is called Plan for Every Part. So we would expect to see a Plan for Every Part database where you have a chance to document all these rights and make sure you're addressing all of them in one place. So again, this is not a Plan for Every Part presentation, but I'll mention that as something you want to have. Okay, so here's the classic material flow chain. I don't know who called it classic. I guess we call it classic. It's what we typically see or what we typically try to implement. And it looks like this. You've got on the left side, you've got the outside suppliers. So we typically call that supply chain issues. And that's not a minor detail. And that's not the main focus, by the way, of this webinar. But it's not a minor detail, especially with the COVID pandemic. A lot of companies, just about everyone has been struggling with supply chain challenges. But we have outside suppliers typically delivering material to our facility. And typically the delivery would go to a warehouse. So the warehouse would be a storage area where the parts are going to be stored, received, and then stored, and then at some later time be delivered to the factory floor. And in a lean environment, those parts typically don't go to the stations or the workstations or the points of use. They go to a supermarket. And the reason for that is this. We want to minimize or reduce the amount of material that we have at the points of use. Because if we store a lot of material at the workstations, then we're causing a myriad number of problems. One is floor space. We're occupying a lot of floor space to store material at the workstation. Second is we're creating challenges for the operators because number one, they've got to find the parts they need if they got too much in front of them. And potentially, if space is an issue, they have to walk. You're asking them to have to walk to retrieve their parts. So our basic philosophy in the world of lean is to reduce the amount of material you have at the station to something that's manageable or maybe minimal right at the workstation. So to do that efficiently, it's hard to do that from the warehouse. So we're introducing this concept, which many of you may be familiar with, of a supermarket. So the idea of a supermarket is you have an inventory supply on the factory floor that lets you feed the workstations efficiently without having to go back to potentially a larger or more remote warehouse facility. So this is the classic material flow plan we would be working on. Now we have an arrow here. It says certified supplier. So the idea is that over time you would work with your supply chain, with your suppliers, to get them to respond to a pull signal and be able to deliver in smaller quantities more frequently and still do that efficiently. So a certified supplier would be a supplier that can respond to a Kanban signal or a pull signal and can do deliveries in small quantities. And by the way, with a 100% quality, because we don't want to have to inspect the material arriving either. So you can see that's not a minor challenge if you have a lot of outside suppliers. It's not something you can just turn a switch. And it's not something under your control completely. So the idea here is that over time, then you would certify your suppliers in these factors that I just mentioned and be able to bypass the warehouse and have suppliers delivered directly to the supermarket. So that in a perfect lean world, you wouldn't need a warehouse. You'd have all certified suppliers and they'd all be delivering directly to the supermarket. But that's, as I said, easier said than done. So over time, that's something it's an aspirational goal that you want to work towards. And more mature lean companies are farther along in terms of having their suppliers, respond and work with them in that way. But that would be the goal. So for most of us, normal companies, you're in transition. So you will have a warehouse, but the idea is over time, you'll be reducing the amount of material in the warehouse and going directly to a supermarket. Okay, So let's get into the 5 strategies you might employ to do this. By the way, I'm not paying that much attention to the chat, but I'll try to look at it once in a while. But we do have a question. Will we get a recording? Yes, you'll get an email in a few hours after this webinar with a link to the recording, to the replay. FYI. Okay, so strategy 1 is zero kitting. So the idea here is to not require the need to create any kits, which requires effort, right? More effort, by being able to provide to operators everything they need for any product within a Kanban methodology. So in other words, the operator has all the parts for all the products kind of in front of them or close by, so that the replenishment, the material replenishment system, can be 100% based on a pure pull signal, right? We get a Kanban signal, this bin is empty, we get the signal, we refill it, we deliver it back. And meanwhile, they have 1 or more additional bins to use with that same part so that the line never stops, right? And we don't have to do anything special. Now, I mention this because this is kind of what we taught for years. Back in the early days of our lean experience, this was a goal. This was an aspirational goal to be able to set up Kanban systems that would be 100% effective. So all the parts are stored at the stations, and this will work. I'm not saying this is not doable, but in the years that have passed, the many years that have passed since we started pursuing that approach, the complexity of manufacturing has increased a lot. For example, one of our clients shared with us, this is during a factory visit a few years ago, they said, hey, this Kanban system that we've been trying to implement, well, it's kind of running out of steam because the number of parts we have to manage has more than doubled in the last 10 years. So just the space, the complexity is, we're starting to, have to go to other methods. So that's basically what's happened. In the earlier days where you didn't have as many models, where the mixed model environment was not as mixed, this kind of strategy could work. But today it's less common. I'm not saying it's impossible, but less common. So we'll just describe what the pros and cons are of this. Basically, the idea is you try to set up a Kanban system at all the workstations, the points of use that store all the material they would need for all the products that could go through that station. And the reason you'd want to do that maybe is because it's simpler in a sense. You have a Kanban system and everything is going to be replenished based on the same system, Kanban system. So you have no need to kit. You don't have to have a separate group of people organizing material and creating sets of parts and delivering them separately. We'll talk about that in a minute, but everything can be replenished via Kanban. Now, the negatives are as follows. The reason why you may not want to consider that. Number one is if you have a lot of parts in front of the operator has to find them, right? Select them. Select the right ones. It's not just a matter of selecting them. They have to reach into a bin and pick the right parts. So you're asking the operator to do a lot of part selection, which strictly speaking is non-value added work, right? You're adding to non-value added activity at the point of use, as opposed to, say, the surgeon approach. Imagine you're in the operating room at a hospital, or you're observing it. Maybe that's a better place to be. You're observing it, and the surgeon has to find the instruments that surgeon needs himself or herself, right? Maybe they're close by, but the surgeon has to walk over and find the instruments. Well, that would not be ideal, right? You have a patient there on the table. And that's not done, by the way. What hospitals do is they'll have like an assistant, could be a head nurse or a technical person, but ideally the surgeon can just reach out his or her hand and they put the instrument right in the hand, right? Scalpel, boom, they put it right in the hand. That would be ideal for a surgical environment. Now imagine in a manufacturing environment, what would be ideal for the operator is, bolt, and they put the part right in the operator's hand and then they install it. That would be ideal. Now, that might be going a little too far in terms of service from the material flow organization, but that would be ideal, right? So no part selection. So when you go down the road of zero kitting and providing all the parts to the operator, someone's not going to get it for them. The operator is going to get it themselves. And this is going to could be a significant level of inefficiency. In fact, we've done some time studies, and the amount of time that an operator is spent doing part selection can be as high as 20 or 30% of their total cycle time. So that would be, not ideal. So that's one thing. The other big negative of this is the more parts you have to present, the more space you're going to need. So we've seen situations where there's flat out no room in front of the operator, like on a flow rack. So what they have to do is store them behind the operator or on the side, somewhere else. So the operator has to either turn around and get the parts or walk up and down. That would not, again, that's not adding value to the work that they are primarily hired to do. Also, another negative is you're increasing the inventory levels. Certainly at that place, at the points of use, the amount of inventory you have there is going up, which is, going in the wrong direction. So in general, you'd have to assess this, and I'll say probably for the third time, this is not impossible, and sometimes this could be a really good solution, but typically where you're not in a super high mix environment. Right, we have a lower number of components. We're a pure Kanban environment where it's fairly straightforward to select the parts, and there isn't a whole lot of space required. Maybe the parts are smaller, et cetera. Those kind of environments, this could be a good one, right? By the way, picking the right part is not a minor detail either. Reaching into the right bin, and so they have pick-to-light systems that you can buy that light up. Here comes a unit, and the bins with the right parts have a little signal light, or sometimes they have a cover that gets opened, or various solutions to reduce the errors in part selection, because that's another risk. Okay, so let's move on. So in this environment with zero kitting, again, we have our standard material flow. We have material coming into the supermarket, but then at the supermarket, we're delivering to the points of use. And if we have too much material, we may have to have carts or something like that. But basically, it's supermarket, supplier to warehouse to supermarket to the points of use for everything. No kitting, but the space, would have to be dealt with if there's no room. So a point of use cart would be a situation where you actually have the parts on a cart. They get rolled up to the station, use the parts on that cart. Here comes another product, requires different sets of parts. Another cart could be rolled in. So that would be, a small changeover, but it could be, just a few seconds or less than a minute to change over the cart. Okay, let's go to the next one. So now we're into the realm of kitting. So kitting is, the work of putting together sets of parts, for a particular unit or a particular order, and organizing the parts offline and then delivering that set of parts to the operator at the point of use. So first one is called a kitting cell. So kitting cell would be an independent area, probably on the factory floor, where people, the kitters, would look at the schedule and organize the kits. The kits could be for a single unit, depends on your environment. A single unit, or it could be a group, right, or batch, or a customer order, however you want to organize that. And that kitting usually happens, at the supermarket itself. You'd have a little work area set up in the supermarket to do that. Now, when would you want to do this? Well, when you've got too much variety or too much floor space, or you want to reduce the selection errors, you would allocate some people to do this kitting. So benefit, you could remove all this material that you had in the previous example from the points of use and just deliver them a kit for the unit or the units that are coming, but a small quantity at a time. So big space saver at the point of use. You're giving them presumably the exact parts that they need. So you're not going to get errors, hopefully. You'd have to error-proof it at the kitting cell, but at the operator level, they're using the right parts, and also the operators don't have to do a whole lot of fooling around. So the part selection process will improve their productivity, right? More time spent actually building the product rather than looking for parts. And even in pretty mature environments, pretty lean, already pretty efficient environments, when you give the operators what they need directly, then you're going to see an increase in productivity. Negative is now you have a new process called kitting, right? So you've got to staff that process. You have to train the people. You have to set that up. You have some additional handling that you have to do. Also, you need to manage the sequence. So in the previous example where you have everything at the station, the next unit that comes down the line is going to be taken care of because all the parts are there. In this case, if you get the sequence out of whack, out of sequence, then you're going to have problems because the kitting people are going to be following a specific sequence. And if what comes down the line changes from that, then you have an issue, right? That, they may not have the parts they need. So this is a very standard kitting process where you're doing the kitting, ideally on the factory floor, but separately, and then delivering the kits to the line. Okay. So it would look something like this. You got a supplier delivering to the warehouse or to a supermarket, as we discussed, and then you've got this new process called kitting, which would typically be happening with the supermarket or close by, and then delivered to the points of use. That is the workstations, right, that are actually doing the work. Right, so that's pretty clean. Okay, so let's go to strategy number 3. This is an interesting one. And this is something that we would encourage you to take a look at closely. So the idea here is you're still creating kits, as in the previous example, but we're trying to design the kitting process to run at the same speed, so to speak, the same takt time as the customer or the consuming process, the assembly line. So we're trying to integrate the kitting with the same takt time as the workstations themselves. So let's explore this in a little bit more detail. We're still going to have a supermarket, but that supermarket is going to be part of the line. It's going to be accessible or built into the line, so to speak. And we're going to have some kitting work that's also built into the line. And so the people in kitting are going to be working at the same rate as the assembly line. And this is a great strategy to use when you've got quite a high mix, like a really high mix, and you need to be able to respond directly, to changes in mix, even at the level of a single unit at a time, every unit being different, that kind of environment. So advantages and disadvantages of this. Well, it's going to be definitely a minimum WIP inventory strategy because you're going to be kitting and feeding the line, at that same rate. So whatever material you have in the supermarket, you're going to have that, but the material in the line is going to be minimal, right, compared to those other strategies that we talked about. So this is really truly achieving our lean goal of one-by-one production or single-piece flow. Remember in the Toyota philosophy, the Toyota production philosophy, they have 4 main goals or North Star goals. One is 0 defects. See if I can remember them. 0 defects. We have one-by-one production, or trying to move towards one at a time type production. The third thing is total elimination of waste. And then the fourth one is respect for people. And that's a whole interesting issue to discuss, what we mean by respect, but engagement of the workforce. So this would be moving definitely in that direction of one-by-one production. So all those things are good. Now, the negative is you've got to design this, to work. You're going to have to use prime real estate on the factory floor because you're integrating it with part of the assembly line. Whereas before you could maybe, do that work, the kitting work aside. Now you've got to do it as part of the assembly line. And you probably need some special kinds of handling equipment, carts or trays. You've probably seen some trays with little sections, like a bento box. So you're putting certain parts in certain areas to organize the material, things like that. You'll have some of that. That shouldn't be a big deal, but you'll need that. Now let me show you something here. So here's how it would work. You'd have a supplier warehouse, you'd have a supermarket, and then basically the kitting process and the line is integrated, is combined, right? It's part of the same flow, running at the same speed. And here's an interesting example that I'll share with you. I don't know how well you can see this on your screen, but basically this is a cart. You can see it's running on wheels. And you see that black tape on the floor? So that's a track that this cart is working on. It's actually a big AGV. So this cart has a motor, right, and a battery, and it's going to run until it reaches certain signals on the floor, and it's going to stop. And what you see on the cart, or maybe you can't see it that well, but I'll tell you what's there. Down below, you've got some small fastener type of parts that are used on a lot of the different models for this product. And those are just replenished visually. This is not a 2-bin system or a multi-bin system. It's like a 1-bin Kanban. And the reason you can get away with 1 bin is this cart is going to be replenished every loop that it goes through. So you don't need 2 bins. If it goes through the loop and there's a bin running low or empty, you can just replenish it as part of that same cycle. And on the top part of the cart, this is a combination work area, workstation, and some of the unique parts that would be needed for this product. So, and this product had something like 300,000 different configurations. Hard to believe, right? I'm not sure I still believe that, but anyway, let's just say a large number of different configurations. So the unique parts are presented on the top of the station. So here's how it works. This cart would go to a workstation. It would stop automatically. The work instructions, because the cart knows where it is, and we have an MES system, integrated. The cart knows where it is, and the work instructions would appear on a screen that's also sitting on top of the cart. So the operator knows, okay, here's the unit, here's the work I need to do. The parts are either on top, or if they're common parts, they're down below. So the operator would do the work, do the quality checks. Yes, Tom, this is familiar. and then release the unit, and the cart would just then move to the next station. Now, in terms of material flow, the interesting thing is when that unit is completed, it's taken off the cart, and then the cart just continues on its loop into the supermarket area, where there are folks back there restocking the cart for the next product in the sequence. Again, stocking the unique parts on top, and then just checking the bins down below, making sure that the hardware items are complete. So this cart is running at the speed of the line, and it's going through a loop so that the replenishment of the cart is also moving at the same speed of the line. So this is pretty cool. This was not a minor project, by the way. This is a major investment. So that's why I say, if it's worth it, if you have the ROI to do this, that's great. But this could be done in much simpler ways than what you see here. This is the Cadillac. I would say this is the Cadillac of this particular kitting integration strategy. But I thought I'd share it with you because it's pretty cool, and it's still running today. Okay, so that is that. So I encourage you to think about this, because I think it worked pretty well, and I think it's a good solution. By the way, the other organization, I guess I'll mention the name of the other organization. When I took a tour of the Toyota factory in Georgetown, in Kentucky, where they make the Camrys, and I guess the RAV4s. There might be some other models there, I'm not sure. Mainly it's the Camry factory. They were doing this exact same thing, but much more simply. They had a kitting cell. They had AGVs, but the AGV was very simple. It didn't have any of the fancy stuff. It was just moving the parts. The AGV was just moving the parts. And the AGV would come around to the line. The line I was looking at was the engine prep line for the Camrys. Right, so they're putting about, 40 different components on the engine block. And then the cart, when the cart was no longer needed there, it would go around on a track, just like you see here, right, with an like a track on the floor, and would go to a kitting cell, which was right behind the assembly line, and it would get restocked. So it's identical concept to this, but much more simple, and I think probably a lot cheaper. It was just delivering parts to the assembly line, but in quantities of like one engine block at a time. And the kitting was done immediately behind. So pretty cool. All right, so next one, strategy 4, remote kitting. So you may have a situation where you cannot kit on the factory floor, which is what we've discussed up to now. I can think of several examples of that. One of them was the material mix was so high that it was just impossible to really set up a supermarket. Because remember, a supermarket has maybe a smaller quantity, but has the parts that are in the warehouse. And to be able to replicate that on the factory floor might be overwhelming just in itself. So what we want to do is do the kitting closer to the warehouse, where the material, where you have more room, right, and the material stored. The other reason might be a safety issue. You might have materials that you're dealing with that you don't want to handle out on the factory floor. For example, this insulation product that I mentioned earlier at the beginning of the webinar, they were dealing with asbestos, I believe, and if I'm not mistaken. So they, when the insulation blanket was done, it was sealed up, but you couldn't really do that on the factory floor. In fact, the folks in the kitting, had to wear masks and things like that. So this may be something that you have to deal with. So in remote kitting, the kitting is done farther away, and so you have more distance to have to move to the line. Other than that, it's similar to the supermarket kitting, but you have to deal with the distance. So it saves a lot of factory floor space. It could really improve the safety issues, because you can isolate the work somewhere else, but it's going to be less efficient in terms of moving things. And also, if you have something unplanned, like this often comes up with kitting, what if the kit is missing a part? I have an incomplete kit. Could that happen? Sure. If we can think of it, it can happen, right? So if I have an incomplete kit and the kitting process is right behind me, then it's a little easier to respond to that, right, than if it's in the warehouse. So that's one of the downsides here of doing things farther away. There will be a temptation if you're kitting in a warehouse to push the kits, meaning run to a schedule and then deliver the kits to the floor and my job is done. So, less of a integration with assembly, because you're not working to that same kind of tack time. And I'll share with you an example of that here in a minute. So this is easy to understand, right? But you're doing the kitting in the warehouse area and then delivering them to points of use. The final strategy is actually probably the most common one, and it's what's done at Toyota Material Handling. It's probably the one that you may end up with, and that is a hybrid strategy. So you're not dedicated to one or another of these kitting strategies or 100% Kanban strategies, you're using a mix. So at Toyota Material Handling, for example, the small, inexpensive items are all managed, as far as I know, and I've been there a few times, they're all managed under a Kanban system. So small quantity, don't take up a lot of space, bins of fasteners, nuts, bolts, washers, that kind of thing. Those are all managed under a Kanban system at Toyota Material Handling. So cards are in the containers. The operator will take out the card, put it in the collection box. That card will be communicated up to a supermarket area where they will assess whether that operator really needs more, if it's a kind of a low use item, but they'll make a decision, refill the bins, and then some cycles later, those bins will be delivered back to the station. So it's like a 2-bin system or a multi-bin system at the workstations. But at Toyota Material Handling, then they have a lot of unique parts, as we mentioned. So all those parts are handled under a kitting methodology. And that kitting could be a kit quantity of 1 or 1-by-1 delivery, like the masts on a fork truck, in front of the fork truck that have the forks, etc. Those are sub-assemblies, basically. And those are delivered one at a time, just in time, basically. Just a few number of masts are allowed, in front of that fork truck assembly line. So that's quite a few parts at Toyota Material Handling are delivered, one at a time. Maybe in sequence sets. Maybe you have a cart that'll have 6 or 8 units on it, but those units are in sequence, right? Basically one at a time. Or very often they will have sets of parts. So what we more typically think of as kits that are prepared in the supermarket area based on the production plan for the day and then delivered to the various workstations as required. So again, a hybrid strategy is probably the most common, and it makes sense, for most environments, where you can reduce the amount of kitting that's required because it is extra effort, clearly extra management, but you don't have to burden the stations with all kinds of unnecessary material. So you do have a little bit more space required, but since we're focusing on the small hardware items, it's not really a big deal. You just have to manage a Kanban system, and you have to manage the whole kitting or 1-by-1 delivery process, almost running independently. Okay, so in this one, you've got a supermarket as before, but that supermarket will either be responsible for a kitting process or the Kanban system. So they have like an independent Kanban system replenishing all the smaller items, and then they have a whole kitting or delivery process managing the larger items, the heavier items, or the items that are very unique, and all the options that they have to support. All of that is managed as a separate kind of kitting or delivery process. Okay, so a couple tricks. We're getting close to the end here. We have time for, I know some of you have been asking some questions, so I want to allow time for that. One thing, if you have especially if you have remote kitting, one thing we ran into when we arrived at this one company was they had tons of kits that were being pushed onto the floor. In other words, the kitting department, before we arrived, had a rule: look at the schedule and try to get the kit for these different orders prepared at least several weeks ahead of need, right? Keep ahead of it. And so they prepare a kit, and what do they do with it? Well, they didn't hold on to it. They just delivered it to the factory floor. So this environment had, I think, if my memory serves me right, they had about 90 or 100 kits. And of course, you know what happens if a kit sits around on the factory floor not being used? Well, if there's a part in there that maybe some other kit needed, it's going to be cannibalized. That's the technical term we use. So, and plus there were it was just confusion. So, where is the kit I need? Where's the next one? We have 100 kits out here, so it was adding a lot of inefficiency to that environment as well. So what we did was we just set up this is very simple. We set up a pull signal. We set up a rack, and that rack contained between 2 days or so, 2 to 3 days. And that was maybe more than they even needed, but we wanted to relieve the anxiety that people on the factory floor had that, hey, I'm running out of work. I'm going to run out of work. I'm going to have nothing to do. So we said, don't worry. You've got days of work on that rack. But the rule was, hey, kidding guys, if that rack is full, you can't deliver another one. So go do something else. But you can stop doing kits because we have at least several days of kits here. It doesn't take that long to build a kit. So so don't worry about it, right? When that rack is full, this is your signal. Keep it stocked, but don't overdo it. And so that reduced 90 to 100 kits down to something like 20, which was not nothing, but big improvement, right? So a little thing that worked for us. Another technique or trick or something, this actually comes from Toyota. The issue here is you may have a kitting process, unless it's integrated, kitting strategy, whatever it was, number 4, unless it's integrated with the takt time of the line, you could be kitting at a different rate or speed than the line. And so you're going to be more kitting to the delivery cycles. And that delivery cycle, could be something different. The delivery cycles of your tuggers, et cetera. So in this case, they created a visual tool. This was, work required in a kitting area to create some of these sub-assemblies. And, to build some of these sub-assemblies and stock a cart for delivery to the line. So they had you can see here, steps, toe boards, covers. This is a fork truck, right? So some of the larger weldments. And so this was just a plan for that area. So they have some idea of the time required to meet that cycle, but it was not the takt time cycle. It was the delivery. It was the speed or the frequency of the delivery routes that they needed to keep up with. So simple things like that to establish some kind of pace or beat for kitting that supports the line and doesn't require that cart to wait. All right. So here we go. We're getting close to the end here. Don't worry. Level of part, how to decide, which technique to use. Again, generally speaking, a hybrid is probably what you're going to end up with. But what you want to do is just look at your environment. What is the level of part commonality? The more part commonality you have, the more a Kanban system is going to be helpful to you, because that same Kanban bin can support a lot of different products. If you have a low level of commonality, where maybe the products are kind of similar, but the parts that go into them are different, almost for every model, then you're going to have a lot of different part numbers and the Kanban strategy starts running out of gas. Right? So level of part commonality. Do you have material traceability requirements would be a question. Many of you don't, but if you're working in aerospace or working in medical devices and those kind of things, you have to maintain a certain level of traceability of the individual parts. And so that's a environment where a Kanban situation becomes more challenging than a kitting situation, where you can control the traceability a little bit more closely. Number of different models you have to deal with, number of active part numbers you have to manage. How far away is your warehouse? Is it in the same building, or is it in another location? Is it 5 miles away? That can really influence your decisions. And then how far down the road are you in terms of embracing mixed model manufacturing? How much of a mixed model manufacturer are you, where you're building different products on the same line and actually mixing them, different products, maybe even as much as one after another. And that will really determine to a large extent the material flow system that you need to have. Okay, so to help you in that assessment, we created this simple little Excel spreadsheet. I'm going to see if this will work here. I'm going over to Files. I'm going to say Share. So you should be able to see, I can't see it on my side, but you should be able to see a couple files that you can download. One is a copy of this presentation, a PDF. The other one is this Excel worksheet. So again, this isn't rocket science. I'm not sharing with you some kind of proprietary algorithms. It's just asking you to do a self-assessment on these various factors, various parameters, and then there's some rules here, just some Excel-based rules based on your score. What a typical material flow strategy might be, recommended strategy might be. So you can play with this. I'm sure you can make it better. All you Excel junkies out there could probably make this better, but at least this will give you a start in terms of kind of assessing where you are. All right. Last thing I want to mention, and then I'll try to answer some of your questions here. We have a few minutes left. We do have a mixed model material flow workshop coming up on October 31st. I know some of you watching this are already signed up. Thank you very much for that. We'll see you there. But this is at Toyota Material Handling that I've been using as an example for some of these techniques. It's in Columbus, Indiana. We set this up because these were times that they had available. I know it's on Halloween. I don't know if we thought about that when we set the date, but it's on Halloween. And some people have said, gee, that's a tough day. But if you have, especially if you have kids. But October 31st through November 2nd, where you'll have a chance to not only learn about all this stuff that we're talking about in this webinar and a lot more in detail, but you'll have a chance to get out on the factory floor of one of the best mixed model material delivery systems and supply chains that exist, I think, in North America. I mean, I haven't been everywhere, but the places I've been, this is by far at the top, the tippy top of the best run material delivery on the factory floor systems and their best external supply chain, which they better be, right? If their name is Toyota Material Handling, they better be good at that, but they really are. So this is a really unique opportunity. Invest in yourself, right? To go there if you can. Okay, so let's look at some of the chat questions. Let's see if I can get to them. The Excel file is not posted yet. Okay, if you don't see it there, I'll send it to you via email after the webinar if it somehow is not there. Okay, let's see. Another challenge. So Raymond says, another challenge in the kitting process, I believe, is the fact that we need to make sure all the parts are in good quality. Yes. For example, if one part is defective, the line would have to stop until a new replacement is brought to the line. And a defect part is red tag. Yes, absolutely right. That's why I think I mentioned kind of in passing that if you have external suppliers delivering directly to the supermarket, then one of the requirements is those suppliers have to be certified, and part of the certification is they need to deliver 100% quality. And what Toyota does, by the way, is they will, when they have a new supplier, or not just a new supplier, when they have a new item, a new part, they will do a 100% inspection of the first, I think it's the first 3 deliveries from that supplier. And if there are no problems, then they will allow that kind of direct delivery to the supermarket. Otherwise, there have to be some corrective actions taken place. So it's not that they take their word for it that it's high quality. They actually will check the first 3. My personal background is in the aerospace environment. Before I started getting into the lean stuff, I was a material manager for an aerospace company. And so, the products we were making were going on airplanes and satellites. They're going into outer space. And so, we couldn't, we didn't trust, no matter what, we didn't trust the suppliers. So everything was inspected when it arrived. That's kind of an extreme example, but we couldn't afford any defects whatsoever. So that it was kind of a burden because it delayed the receipt of material coming in. Sometimes we needed a part, and so we almost had like an expedited inspection track, for the stuff that production was waiting for. But it was really a burden, but we just couldn't take the risk, right, of trusting them. Now, if you don't have that level, you at least want to verify that the first units. And of course, if a defect happens later on, that supplier becomes decertified. If you find a defect, a part defect on the factory floor, that red flag goes up and that supplier is immediately decertified from being able to do that, deliver directly to the supermarket. Okay, let's see what else we have here. Do companies usually have the people in the kitting classified as direct or indirect? we had a challenge in a previous employer that was hard set about the ratio of direct to indirect employees. That's a great question. Direct, the classification of direct or indirect normally means am I directly adding value? Do I have my hands on the product? And indirect is like support people, right? Like typically material handlers would be classified as indirect. But I guess our feeling is that it would be better to think of everyone as one big team and not really classifying people as direct or indirect in that way. And in fact, your cost consideration, the cost concern of having too many indirect people driving up cost, that really shouldn't be the issue. It should be, what is the total cost? Including the impact on operators. So if you can improve operator productivity by having more handlers, shouldn't that make more sense? So the idea of having a ratio probably is not the best solution, but you do want to look at, making things as efficient as possible. That's not in debate. The question is, if I can add some more handlers, but I can get a big productivity boost on my assembly line, wouldn't that be the right choice? And if you have this ratio, then that's going to get in the way of making those kind of choices. All right, I think we probably reached a good stopping point. So again, if you have the opportunity to join us at Toyota, please jump on it. It's a great experience. Any other questions that you have? Here's our contact information. So mine is that first email address. Gerard Leone will, I'm sure, appreciate hearing from you as well. So with that, I'll let you go. And thanks for attending. Appreciate it. Bye now.